All right. We're going to finish chapter 1 and start chapter 2 today. In this section, we're going to talk about solving inequalities. We did last week or week before, we did the inequality worksheet. So the set notations, interval notation, and graphing. Now we're going to look at how do we solve inequalities. To solve inequalities, treat the inequality symbol like an equal sign. We need the addition principle. The addition principle says this. If A equals B, then if I add something to A, I have to add it to the other side as well. So if X equals 3, then X plus 2 equals 3 plus 2. That's the addition. So whatever you do one side, do the other side. Same thing with the multiplication principle. If A equals B, then if I multiply something to A, I have to multiply the same value to C. If X equals 3, then 2 times X is the same thing as 2 times 3. Again, these are like no-brainer. Duh, we knew that. All right, so let's look at how to solve these things. Example 1. Three x minus 5 is less than 6 minus 2x. And then B, 13 minus 7x is greater than equal to 10x minus 4. Yeah, I said, treat this like an equal sign. First step, you have x's on both sides. Which one do you move? How? Always move what? Always move the smaller to the larger. Which one's smaller, 3 or negative 2? Yeah, so we add 2x to both sides. Three plus 2 is 5x. Minus 5 is less than 6. Anything that's not on x goes to the other side. Get rid of the 5. So we have to add 5 to both sides. Five x is less than 11. Then what? Divide by 5, both sides. Very good. So x is less than 11 over 5, or 2 1/5. Plus 5 goes in 11 twice with 1 left over. So what form is this in? It's either set notation, interval notation, or graphing. Set notation, because it has the inequalities. So put it in the other two forms. Whenever you have to put it in the other two forms, it's always easier to put it in graphing first. So here's 11 over 5. Is it an open or closed circle? Open because there's no line. What side is shaded, to the left or to the right? Well, if you have X on the left side, follow the arrow. It says go that way. So where does it go to? Infinity?
Wait. Has to be less than 2/5.
Negative infinity.
Oh, negative.
Infinity is on this side.
All right.
Yeah. So those are my X's. Which the reason I'm saying always go to graphing, because now for the interval notation, I have the beginning and the end. So it goes from negative infinity to 11 over 5. And they're both parentheses. So there you have all three methods. And how about the other one? The next one. What do we do here first? So what do we do first?
Move the 7.
How?
Add.
Yeah, since this is a negative 7, we have to add 7x to both sides. So we have 13 is greater than equal to 10 plus 7 is 17x minus 4. Next step. How? Add 4. It's a process of opposites. Those cancel. 13 plus 4 is 17. Next step. By, right. Divide both sides by 17. So 1 is greater than equal to x. Now, we don't have to keep it in this format. This is the answer, but we don't have to keep it there. A lot of people like to have the x on the left-hand side. So I can just flip this whole thing. There's x and 1. This thing has to keep on pointing to the x. So there's my first format. The next one, I put it into graphing. So there's a 1. Is it open or closed circle? Which direction do I shade? Very good. Left, and it goes to negative infinity. So I'm going from negative infinity to 1, and it's a bracket. Pretty easy. The only stipulation is this. What if I had that? What if you have x only on one side? Let's look at it two ways here. There is two ways we can solve this, and both ways will give us the same answer, but one way is maybe easier and safer for us. So first off, you said move the what first? Yeah, subtract 2 from both sides. 5 minus 2 is 3. And then what?
uh,
Not yet.
I mean,
Yeah, because of the negative, to get rid of the negative, you switch everybody's sign and you switch this sign. So this becomes now a -3. That now flips over. And that becomes a positive 3x. So yeah, if you have a negative in front of the x, change all the signs and change the direction of the inequality. And now we could divide by 3. So -1 is greater than equal to x, which is the same thing as x is less than -1. And then we do the graph and everything. But if you don't want to memorize all that stuff, there's another way you can do it. Since you have the x on one side and it's negative, move it to the other side. What if we add 3x to both sides to make it positive? So we have 3x plus 5 is less than equal to 2. So if you do it that way, then you don't have to worry about flipping anything or changing anything. We subtract 5 from both sides. Two minus 5, since they're opposite signs, 5 is bigger, answer is negative. 5 minus 2 is 3. And divide by 3. So it's -1. You can do whatever method you want. If you don't want to memorize it, just move the x. If you only have one x and it's negative, move it to the other side. If you have one x and it's positive, leave it there. So you get the same answer. So far, so good. Example 2. Find the domain of these functions. F of x is the square root of x minus 6. And h of x is equal to x over square root of 3 minus x. So what's the domain here of this first one? Remember, what does the graph of the square root function look like? Yeah, from where? From the origin. So it starts at 0. So the smallest number you can have inside there is 0. That's what we do here. Take this number here, set it equal to 0, and that tells you where you have to shift it to positive 6. Yes, so because this, you can't get a negative in there. I'm sorry, my fat head out of the way.
I got it.
I should put it over there.
Thanks.
Yeah, so if you set inside there, set it equal to 0. So my domain is x has to be greater than or equal to positive 6. Y equal to? It can be equal to 0. Yeah. So 6 minus 6 is 0, and that you can have a square root of 0. Now let's look at B. What are the rules about fractions? What can you not have?
Negative on top. No, it is on the bottom.
You cannot have a 0 on the bottom. So that's one rule. So in other words, this equation here cannot equal 0. What else can you not have with respect to radicals? This cannot be negative. So the first thing we do is take what's inside there, set it equal to 0. We know it equals 3. But it cannot equal 3 because if you put 3, it's 0 on the bottom. So if we look at our graph, our domain, we cannot use 3, but we can go all the way close to it. But look at, since x is negative, what does that do with the graph? If x was negative here, what would it do with the graph? It would flip it across the y-axis. Because remember, you cannot have negatives inside there. So x, in order to cancel this, x has to be negative. Because the coefficient of x is negative, that means we reflect it across the y-axis. So my domain is x has to be strictly less than 3. It cannot equal 3. Because if it equals 3, then we get 0 on the bottom, undefined. Make sense? So yeah, there's a lot of things that we have to remember, but those fractions, you cannot have 0 on the bottom. Radicals, you cannot have negatives inside there, which is why we went through the library of functions last week. All right, let's look at the example. Or now we're going to get compound inequalities. So far, we've only had some equation is less than or greater than some other equation. These are called tripartite. We can have equations that look like this. It says graph the solution. Now, when you have something like this, this actually means you have two separate equations. This is one equation, and this is another equation. We're solving for x. So here's the part that's important. Whatever you do to get the x by itself, whatever you do to that one, you have to do to the outer ones. So what do I have to do first to get x by itself? To get x by itself, what do we have to do? Subtract 5 from all three sides. So we subtract 5 from all three sides. Negative and negative, its answer is negative. 5 plus 3 is 8. 2x less than equals 7 minus 5 is 2. There, we're only looking where the x is. To get x by itself, we have to do what? Divide by 2. So it's negative 4 is less than x is less than equal to 1. Which means our graph starts at negative 4 and goes to 1. Is it open or closed circle at negative 4? And at 1? And x is between there, so it's that. These are called conjunctive inequalities because they share the same points. They overlap. Because what's really happening, remember I told you there were two separate equations, this equation and that equation. On this side here, we know x is greater than negative 4. So x is greater than negative 4. That's what this side says. What does this side tell us? X is less than or equal to 1. So it's over here. Now, where do they overlap? They overlap here. From -4, it's open, to 1 is closed, and they overlap right there. The next type of inequalities we have are called disjunctive inequalities, which means they have nothing in common. The conjunctive means they overlap. Disjunctive means they do not overlap. And this is an example of this one. So we have 2x minus 5 is less than equal to -7, or 2x minus 5 is greater than 1. Notice we have ors, so it means that our graphs are going to go opposite directions. So solve both of these independently. On the left equation, what do? We have to add 5 to both sides. We have 2x is less than equal to -2. Divide by 2. X is less than equal to -1. There's my first half. X is less than or equal to -1. That's that one says. This other equation, solve for x. We have to add 5 both sides. 2x is greater than 6. Divide by 2. So you have to solve for x. And x is greater than 3. X is greater than 3. Strictly greater than. So it's no. Because there's the word or here, which means if we look at it as a set notation, we have negative infinity goes to -1, unioned with 3 to infinity. When we did the inequality sheets, we talked about these. If they go opposite directions, it's a union symbol. So our graph will be both of these together. This is my graph. Because it says or, I have to take both parts of the graph. Now, is it possible to switch it between conjunctive to disjunctive or vice versa? Yes. What if I had this equation? -3 is less than equal to 3 minus 2x is less than 9. Because this looks like a conjunctive. The x is between these numbers. But let's work it out, see what happens. What's my first step? Subtract 3, because we have to get rid of this one first. So subtract 3 from everybody. -3 is -6. Less than negative 2x are equal to 9 minus 3 is 6. Here's a negative in front of our x. So when we change this sign, we have to change everything. We have to change the signs of the numbers as well as change the directions of the inequalities because we're changing the sign of x. We flip it across the y-axis. So this number now becomes a positive. This one becomes greater than equal to 2x greater than negative 6. Then divide by 2. So 3 is greater than equal to x is greater than equal to negative 3. Do we have to keep it in this format? No, we can flip it. We can pretty much, if you take your paper and flip it over, we have negative 3, the arrow's pointing at it. The arrow's pointing at it. So far, so good. Let's look at an application, a word problem. And this will finish up chapter 1 for us. For her interior decorating, interior decorating job, Natalia can be paid in one of 2 ways. Plan A, $250 plus $10 per hour, or plan B, $20 per hour. Suppose the job takes n hours. N, not 10. For what values of n is plan B better? So how do we set it up? What values of n is plan B better? So what we're looking for, when is plan B better than plan A? That's what it's asking. So what's the formula for plan B? $20 per hour. 20n, very good. As opposed to plan A is 250 plus 10 per hour. So it's 250 plus 10n. Solve for n. Subtract 10n from both sides. Divide both sides by 10. So for any job greater than 25 hours, plan B is better. That's how I do it. So once you have the formulas and you want to make one better than the other, that's how you do it. You have to set any inequality. All right, that does it for chapter 1.